Hi, I got a question about the different parameter space. What do I mean by packed, unpacked, and compacted versus expanded? And I realize I use a slightly bad terminology, but let's try and explain it as simply as I can, yeah? So when we look at G200 kg, they've gone to the trouble of taking apart MS CDR 70, and in their model, you get the F0 52 0 58. This is a different one. This must be the MS50 or something, yeah. So we normally get 61 28, which is the sysex command, and then you see they've got these bits 0 to 7, and they're describing up here. He gives a nomenclature, whether it's a tap tempo, whether it's a patch name, whether it's a DSP 4-bit or whatever, yeah. um, so what he's done is to carefully change and map out how each parameter has changed the raw sysex. And there's nothing wrong with this. And in fact, you can use it. So someone asked, how do you find the tempo bits? Well, look, they're here. So tempo 2 1 7 6 5 4 3 2 1. I don't know where tempo 0 has gone. I don't know if that's important. I don't know if he explains it. Let's have a look. Um, so that's the simplest way of playing with stuff if you want. Yeah, look, TT naught. So I don't know where TT naught has gone. Has it gone? I think it's gone somewhere crazy. Maybe we should look for it actually. Look, wait a minute. Control find TT0. See if it's there. F3. No, sorry, wrong one. Ah, where did TT naught go? Next one. There. So byte 125, bit 012. Yeah. Now so that's one way of doing it. So if you want a simple way of doing it, you could patch that little bit and those bits there and you'll be okay, yeah? That's one way of doing it. But what do? I basically, let's turn the editor on. Well, let's just identify the pedal. So I've generalized this because I do it in a different way anyway. I already knew about this packing and unpacking, and I prefer to work in the space on the pedal and not in the sysex space, yeah? So let's have a quick look at the identify shell, and this tells me I've got a 61 hex 61, which is a MS70CDR. So now I can turn the editor on. Yeah, I can rm star.bin. I don't want any of the binaries. Then I can say get more data and get current patch. And when I do that, it will pull down the current patch. And this is the same space that G200kg is talking about here. 146 bytes like that. Okay. And actually, if you want to have another look, Phil the Frill, which is mentioned on my main page, he also has done some work in this area for setting tap tempo directly, which is cool. So those are two people you can look at to do it in the raw space. But I'm not only working on MS70 CDR, I'm working on other pedals. So if you're only interested in the 70 CDR, just look this bit up in his MIDI messages, maybe look at what Phil the Frill's doing and stop, and that's that. But because I'm working on a lot more pedals, I do a bit more. Okay, so I read the data in like he does, and now I can say to it, MS70CDR patch unpack current patch, and this will give me what I think is in the pedal. So here's the raw space again. Again, I strip off the first part, which is up to the message type, and then I pull out the information, and the hyphen there is the 2D, and there's the C, there's the D, there's the R. But notice these blank bytes here, there, and 8 on. So 1, 2, 3, 4, 5, 6, 7, 8. So these here are control bits, and if the values are set, it determines in reverse order whether you set a top bit on this 7-bit or that 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 7-bit. So 4 in fact is not that one, not that one, 40, sorry. It will be like up here that you set, yeah. So I decode what's in the parameters, same idea as what he's done, but it's just a more general approach. And actually, the way I did it is a bit kinky. I already do this mapping into the same memory space that the pedal uses natively, and then I use a set of Python to do comparison and look for the bit changes. If I did it in the unpacked space, the raw sysex, I would still be able to find it, but trust me, it's a lot harder if you're working on multiple pedals. So what I do is I convert it and break it down into the smaller space. We see a 5.3 here, and there it is, 5.13 there. And when we go up here, we also see a 5.13 there. But what he's saying is that one of these bits further up will also be changed according to tempo. Where was it? It was down here somewhere, wasn't it? Oh, there, look. So byte 125, which is what? 20 in from the end, yeah? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, there. So because this doesn't have a top bit set in its nomenclature, you don't need to set this. So you would be able to just replace the 2 bytes if you wanted to. But as soon as you go past a certain number, then you might need to modify this. Now, I haven't thought about in my mind yet whether you'd ever have to change it, but you might need to, okay? Because I'm working on general pedals, I want to work in this space. And what I do when I print out a column guide. So this is the column 0 to 17. This is the unpacked, ooh, cancel. This is the unpacked value of fx1. And actually it tells me it's blank, but it's on, okay? This one is on. So it's got 1, 2, 3, 4 fx that are all on. That's nothing. That's whatever 40, hex 40 is, that's 20, that's 11, okay? And these give us some indication of what group the effect is in. And this is some indication of the parameter values. They're packed in a different format to what you'd expect. And down here is the tap tempo again, with the bit 4 set, yeah? So now in my model, if I want to set the tap tempo, then I would say to it, what do I do? I do MS70CDR patch tempo, I don't know, 127, no, sorry, current patch, and I want to set it 127, okay? And that's written new tempo, and then I would say dot slash load sysex file, new tempo.bin. That should send it to the pedal, and I see 127 on my screen, yeah? So that's worked, okay? Um, So again, what are we doing? It's very similar to what we saw a moment ago. In normal bits and bytes, you have 8 bits in 1 byte, but MIDI has to send a 8-bit control start, an 8-bit control end. So there's the 8-bit there, there's the 8-bit there, and everything else has to be 7 bits. But the pedal probably wants to store numbers like thousands or whatever, which are much bigger than 7-bit. What means 7-bit? Well, here are the bits here, starting from the smallest value working upwards. 7-bit has 7 ones, and the most you can do is 1 1, 1 2, 1 4, 1 8, 1 16, 132, 164. Yeah, and when you add that up, you get 127. Whereas this one is 108 bigger, you get 255. Yeah, so those are the maximum values you can get. So when you look at these, each one of these is a nibble. That's a nibble. That's a nibble. Nibble is 4 bits. Then here's the representation here, and the top bit is only set in these ones here, half the space, which is 8, 9, A, B, C, D, E, which is 8, 9, A is 10, B is 11, C is 12, D is 13, E is 14, F is 15. So in this space here, you'll only see a top bit set there and there, and everything else will be lower. But when we unpack it into this space here, you can see we've got some 8 set there, like 80. So that means that this rep and there's a D there and a B there. So this is the memory space inside the EEPROM of the pedal. And it changes depending on what zoom pedal you use. So I decode it and work in the memory space that's inside the PROM because it's just so much easier, trust me. It's much harder to explain, but it's much easier to work with. I have programs that will sit there and map the space. I can map the space in the sysex space, but there's a whole load of bits going on. It gets really complicated to explain it. When you pack it, what you'll find is a few bytes will change, but you won't get they'll be adjacent to each other in general. Not they don't have to be, but the way Zoom does it, they pack it so it'll be 1 or 2 or 3 bytes adjacent to each other that will change. Not this bit here changing and that bit changing, and it's a much nicer way to work, in my opinion. So again, what we're doing in the code, if we look at the unpacked.cpp, we're reading in the value. Oops, hang on, let me vim it. When we look in the unpack space, we're reading in the value, and we're starting at 5 because we know that that's where the 28 will live. And then we're walking through and saying, okay, does this thing have a high bit set? Yeah. So if the higher bit of P is set, and 2 to the P is because we're setting these values like this. So in fact, we're using this one here. So it will never have a top bit set, and it's got these ones here. So the first time round, we're looking for that. Then we're looking for is that set. Then we're looking for is that set. And then we're looking for is that set. 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 And we've checked every single possible top bit in the 7-bit space. Okay. Oh, sorry. Make that open. So if there's so if those bits are set as we walk along each byte, so as we walk along each byte in the raw sysex, if the bit is set, then we add on 128 to that byte position. Okay. Otherwise, we leave it untouched. Now that has the effect of contracting. I call it unpack, but it contracts it. So when we look up here somewhere, I think we had the data. We're asking, da, 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 da. We're asking, does this have some bit set? And if it does, sorry, that's got a 41. So that's got a, no, that's the output. Sorry, I got it wrong. Input, there we are. So that 8 set there is 2 to the 8 is 3. So there's 8 there, look. So if that one is set, and it is, then 1, 2, 3, the fourth one, 1, 2, 3, 4, 5, 6, 7. We have to go backwards. That's 2, 3. That one gets 128 added to it. Okay, and these get removed, and whatever 8. 1, 2, 3, 4, 5, 6, 7, 8. They get removed. So this column gets removed, and that column gets removed, and we see that one of these values gets a bit set. Yeah. This one more values get set. Yeah. And that has the effect of compacting the map, and then you don't have to deal with all of this position n bit whatever. Now, sure, you can work this way and you can use this, but it's an awful lot of programming to do it, and it's an awful lot of special cases. But if you work in this space where you've converted this into its real representation as it is on the pedal, then it's, trust me, it's much easier, because when you change the tempo, only 2 bytes, and in fact a subset of bits inside those 2 bytes make a difference. But this is how you would love to send it in binary to the pedal, but you can't do that. You have to send it back as sysex. So at this point, we need to vim pack. Well, this is what sends it back, and the pack says, okay, we've got it in this binary space. Now we need to send it back um, in the sysex space. So now we have to say, oh, if a top bit is set in a given set of bytes, then we need to make up this control byte. I can't remember what I called it, BVT, I think I called it, BV, byte value. And you need to sort of hit that value up a bit to set the pattern. So you're setting the single bit inside a byte, and then once you've done that, you write it out to the stream, and then you echo out the 7 bytes, the 7 bit bytes that you use to try and determine if this should be set. So basically, it's a two-step thing. You read the sysex, you convert it from 7-bit sysex into 8-bit numbers. Then you do all your analysis in that space, you do your setting in that space, and then you convert it back to 7-bit in order to send it back to the pedal. I know this probably seems complicated, and if it is, and you're dealing specifically with an MS70CDR, follow this dude, yeah, and work in this space. But if you want to work in not just zoom pedals, but any type of hardware that you want to reverse engineer, I think you need to work in this space, because this is what's really happening. And even this isn't quite right, because I say it's what's really happening, but let's go back and look at the tempo. Hang on a second. So when we look at the tempo and we unpacked it here somewhere, give me a second. Um, uh, 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 513, yeah. So 513 was here. Um, when we look at that, it's found the value 0513. But what it's really looking at is like that. It's reversing the values, um, and so even when you see it read like this, left or right, the zoom is going the other way around. It's a different endingness. So you have to look at it as 1305, and then you can begin to see the pattern. Yeah. So it's all a bit messed up. I mean, I don't know. Give me a second. I don't know if I've got something here, but I was working on the G5. I haven't published this work. I will do one day, but I've been quite busy. No, that doesn't look like it. Oh, I know what it is. Ah, it's in here. Indulge me a second, please. Zoom pedal G5. There's something I've been working on. Here's a load of pictures, right? So if we do FEH, which draws pictures, I don't know, 8, 4 dot dot. I think this is FX8 parameter 4. Yeah. When I hit that, you see it brings up this value here. So FX8 parameter 4 is only byte 90, and it's actually setting um, the bottom range with a bit on off and the top range like that. And from this, I can work out the bit patterns that have contributed to the setting of that byte. If I did this in the raw sysex space, I'd have a whole load of extra control bits coming in. It would get very confusing very quickly. But by working in the machine space, for want of a better word, the 8-bit space, my programs can auto-analyze and pull apart the pedals much quicker. So that's why I do it. If you want a simple gratuitous answer, you don't want to think too much, just follow what this dude's done. But as soon as you move to another pedal, you're going to have to change it. Whereas here, I've got in Zoom Pedal Fun alone, I've got up one, sorry, dot dot slash Zoom Pedal Fun. Here I've got quite a few pedals I'm looking at, yeah, and I've got even more up here, yeah. So there's a lot more in here going on, yeah. So that's why I do it. If it's confusing, I'm sorry. I'm not trying to be smart. I'm just trying to say that this is what's really going on inside the pedal. And if you really want to see it, do it that way. Um, and it's also the way Manjul does it in his stuff. I did this years ago on a Miniac, yeah, which is a different kind of synthesizer, same idea. And when you look at any sysex from the 1980s onwards, which is kind of when I was really into this stuff, that's the way they do it. So I'm just trying to say that please try and get into the 8-bit space. It's the way that the machine is really, really working, yeah. And you'll be able to understand things better if you do it that way. Okay, thank you for watching. Sorry if this was a bit involved and boring, but I did get asked about it and I said I would try and explain it as best I can. Thank you and bye bye.